Hi, in this video we are going to solve the system of three equations with three variables that you see on your screen. To start, we need to decide which variable to eliminate. For x, notice that 2 does not go evenly into 3, neither does 4. So x is probably not a good choice to eliminate. For the y's, notice we already have a positive 2y and a negative 2y, and also 2 does go into 4, so y is probably a good choice to eliminate. Let's actually write that down. Eliminate y. Now we need to pick two equations and eliminate y. It doesn't matter which two you pick, let's just pick the first and the second. I'm going to say let's copy those two equations, those first two equations, on the left side of your page. 3x minus 2y plus 7z equals 55, and negative 4x plus 4y minus 5z equals negative 63. If we are going to eliminate y, we need to have opposites as coefficients or the numbers in front of the y's. So we somehow need to change this negative 2 into a negative 4, which will then eliminate with a positive 4. To change the negative 2 into a negative 4, we need to multiply everything in that top equation by a positive 2. If we distribute a 2 to all terms in the first equation, we'll end up with 6x minus 4y plus 14z equals 110. I would write that little slash through your z if there's any chance that your z and your 2 could get confused. I know with my writing, if I don't put that slash through the z, it would look too much like a 2. So there we have our first equation. I'm going to take the second equation and just copy it down below to help us stay organized. Negative 4x plus 4y minus 5z equals negative 63. Since our y's have opposites, negative 4y and positive 4y are opposites, we are now ready to use the addition method to add these two equations together. 6x plus negative 4x is 2x. The negative 4y and the positive 4y eliminate, which is why this is also called the elimination method. 14z minus 5z is plus 9z equals 110 minus 63 equals 47. Let's put a box around this equation because we just eliminated y. Now we need to pick two different equations and eliminate the same variable, eliminate y again. Since the first equation and the last equation already have opposites in front of the y's, let's pick those two. 3x minus 2y plus 7z equals 55, and negative 2x plus 2y minus 2z equals negative 30. I just copied those equations on the right side of the page. And since the y's already have opposites for coefficients, we can add these two equations together right away. 3x plus negative 2x is just x. Negative 2y plus 2y eliminates. 7z minus 2z is plus 5z. And 55 minus 30 is 25. Let's put a box around this equation also, since we just eliminated y. Caution, make sure that you eliminate the same variable both times. If you eliminated different variables for your first two eliminations, you would probably get totally lost and get the question wrong. But we eliminated y for both of the equations, so we're good. Now, we're going to take these two boxed equations and do a third elimination. The first boxed equation here, let me rewrite it, was 2x plus 9z equals 47. And our other red boxed equation from the other side of the paper, x plus 5z equals 25. This looks like older stuff that you already know how to do. We want to choose a variable to eliminate here because 1x does go into 2x. X would be your best choice to eliminate. Let's multiply the second equation by negative 2. Distribute the negative 2 to all three terms. We get negative 2x minus 10z equals negative 50. To stay organized, let's copy that other red boxed equation down below. 2x plus 9z equals 47. And now, because the x's have opposites in front of them, we are ready to add those two equations together. Make sure that you only add when something eliminates. If you're adding and nothing eliminates, you're doing something wrong. But here, negative 2x and a positive 2x eliminate. Negative 10z plus 9z is negative 1z equals negative 50 plus positive 47 equals negative 3. Divide both sides by negative 1 and we get z equals positive 3. So now we have one of the three variables, but we've actually done most of the work. We have our z equals 3. We're now going to take that z equals 3 and substitute it into one of those boxed equations, one of those two red boxes. It doesn't matter which one you pick. I'd say the second red box looks a little bit easier, so let's pick that. Second red box is x plus 5z equals 25. And since we know what z is, we just found it. We just found that z is equal to 3. I'm going to take that 3 and stick it in for z, leaving us with x plus 5 times 3 equals 25, which means we have x plus 15 equals 25. So x is equal to 10. Now we have an x and a z. We only need y. To find y, we're going to go back to your beginning equations. Pick one of the three beginning equations. It doesn't matter which one. I'd say the first one looks as good as any of them. So we're going to take that first original equation, 3x minus 2y plus 7z equals 55, and substitute your x and your z into that equation. So 3 times, you just found your x to be 10. I am using colors intentionally here. Minus 2y plus 7 times, we found your z way over the other side of the paper was 3, equals 55, which means we have 30 minus 2y plus 21 equals 55. Combine your 30 plus 21 to give you 51 minus 2y equals 55. Subtract 51, negative 2y equals 4. Divide by negative 2, and y equals negative 2. Now you have your x, your y, and your z. When you write your answer as an ordered triple, like an ordered pair, but with 3 terms. With your x first, comma your y second, comma your z third. So your final answer is the ordered triple, 10, negative 2, 3. To check that answer, you could put the 10, the negative 2, and the 3 into all the original 3 equations. If all 3 of them are true, you can certainly use your calculator, but if all 3 of them are true, your answer is right. If not, you made a mistake somewhere. I hope that helps a little bit. Thanks for watching.